Alright, when you have variables on both sides, we need to get them both on the same side before we can do inverse operations. So I like to move the smaller number, and that's just a preference. It really doesn't matter which one you move. So I'm going to move negative 17x by adding a positive 17x to each side. That will cause that to cancel. So signs are different. We subtract 5x plus 7 equals 12. Now it's just like a two-step equation. Do inverse operations. So subtract 7 from 12. So 5x equals 5. Divide by 5. X equals 1. For this one over here, same thing. We need to get the variables together. I'm going to subtract the smaller one. Remove the smaller one by doing the opposite. That cancels those. So 4 plus 12x equals 7. And we subtract 4 from each side. So 12x equals 3. Divide both sides by 12. Okay, 12 won't go into 3 because 3 is smaller, but we can reduce 3 over 12 to 1 over 4. Okay, let's go over here. Now the smaller one is on the left, so I still like to subtract the smaller one, but again, that's my preference. It doesn't matter which one. So we end up with 6 equals 4x plus 6. Subtract 6 from both sides. So 0 equals 4x. Then we divide by 4. And 0 equals x. Let me point out here, if you have an x, you have a solution. 0 is a solution. We'll look at another example where you don't have a solution. So keep that in mind. If there's an x, still there is a solution. Okay, and then the example over here, subtract 4x from each side. So x plus 9 equals 5. Subtract 9, and x equals negative 4. Alright, when we go to solve this, and we get the variables together, notice they're the same thing. So if I go to subtract, minus 5x on each side, it cancels in both places. And I end up with negative 5 equals negative 2. Well, that's impossible. Negative 5 can't equal negative 2. So when that happens, your answer is no solution. For this example, we can change it to 3x plus 8 equals 3x plus 8 with a double negative. Now, if I go to move the variables again, same thing happens, almost, they cancel, and you get 8 equals 8. However, this is a true statement. 8 does equal 8, always. No matter what x is, x or 8 will still equal 8. So when that happens, we say it's all real numbers.